Dear student, today let us talk about the CMM. What is CMM? CMM means coordinate measuring machine. So what is the function of CMM? The function of CMM is to measure some geometrical features like angle, diameter of circle, diameter of sphere, cylindricity, roundness, flatness, bend angle, and all these geometrical features. Now, dear students, let us see the drive system here. How the drive system is going on. So this is joysticks. So there is a for servo motors driving is here, but lubrication purpose we are using the air bearings. So for air bearings we are importing here high bar air pressure. The air pressure compressor is outside is running now, and we have a hose pipe is here. Through the hose pipe we are supplying the air inside the machine. So you can see the air bearing here. This is the air bearing. This is the air bearing, and this air pipes is there, and this air bearing simply you can see here, and this side also air bearing. So this as I told earlier, this is a y-axis rail. Above the rail, this column is standing here, and all drive also you will have a air bearing. Here also you will get a way. Now come for measuring procedure. So we have one joysticks already I have told. So for measuring purpose, in z-axis we have attached one Renishaw TP8 probe systems. Here one small stylus is attached, and at the end of stylus we will have one small ball is there. So this ball diameter is known by machine. It is calibrated one. So for measuring purpose we will drive like this. This is z-axis, this y-axis, x-axis, this is x-axis, y, like that. So for measuring purpose we have one software. Suppose you want to measure the angle of this job. This is a plane one, this plane, angle between this plane, what is the angle the value of this angle, and different geometrical features is here. This is circular object, this also circular, this depth also here. So suppose you want to measure this angle between this plane, so you have to drive here like this, and now go to software first. In software, this is inspection software, so different features is there. Suppose you need a plane features, so I am selecting here plane. You need 4 points here. So for collecting 4 data points, you now come for machine. You see the machine now. So I am touching one point here with the joystick. It is recorded point now, and next it is also touching next point also. After touching, it will automatically deflect back like this. 3 points and 4 points I am touching now. 4 points. It is completed. One plane recording is completed. And next, you see next plane I am touching here 1 point. Again other point. Total you need 4 points. 2 points has gone. Again 3 point, and last point will touch now. Yes. All 4 points is completed in this plane also. Now for this angle you come in software. you need angle now. Angular distance is there. You just click it. Now select first elements plane 3 and next element plane 4. This means whatever plane you selected last measurement, that is. So evaluate now. After evaluating, you will get a 90.0942 angle for this job. Like this way, whatever features you want to measure, just bring it. Suppose here this cylinder diameter you can measure. Before measuring, you just select in software the cylinder. Suppose here, where is cylinder? This is cylinder. This cylinder needs 6 points total 6 points. So I am touching here 6 points to measure the diameter of this cylinder. 1 point has gone, surrounding 6 point, 2 point has gone, 3 point has gone. Now 4 points, 5 points, yes. And last 6 points is completed. Now we can set the diameter of this outside diameter of this cylinder block. See, friends, what is this? What is the diameter? Radius, diameter or radius, like that. Cylinder, the cylinder 1, it is showing 70.1319 millimeter. This is diameter. So like this way, you can measure different features, geometrical features. So flatness you can measure. Suppose I want to measure the air flatness, this surface flatness of this object. See, now come in software. Let's see the software. The features is there. I want to select a plane. Plane number 5. It will become plane number 5. 1, 2. Total need 4 points. 4, 3, 5, 4. Now come in software. Tolerance. What is the flatness? Flatness options is here. Flatness of which plane? This is was 551. So evaluate. 0.0030, almost 0.03 micron. This is the flatness. So like this, roundness also you can measure. Now lastly, what is the flatness and roundness? You see here, suppose circularity. Suppose this is circularity. What is circularity? This a black line you have seen here. Black line is real object, and inner red and outer red is there. So inner red is some points imaginary circle, and outer circle is the some other points imaginary circle. So between this lower red and outer red, this is the circularity of this circle. And flatness also, you see flatness. This is flatness. How flatness is calculated? This is suppose your perfect flat object with the z-axis. With the z-axis, so lower red and upper red. So your black line is real object, and your lower rate and upper rate is some circle formed by the different points. So difference this lower rate and upper rate region. What is the region? This region is flatness. So if you want perfect flat, then this value lower rate and upper rate should be 0. Here also, if you want perfect circle, then inner rate and outer rate region value, that value should be 0. So, and straightness also you can check here. If here's a inner rate and outer rate is there, black line is a real object, and if you want perfect straightness, then value of the t, that means straightness value should be 0. So like this way we can check different features like the straightness, flatness, circularity, diameter, cylindricity, and so on. So now the measuring procedures is explained. It is now completed.